All right, so let's continue to apply our newfound knowledge of the central limit theorem. In the United States, the year each coin was minted is printed on the coin. To find the age of a coin, simply subtract the current year from the year printed on the coin. So, for example, like it's 2010 and the coin says 1970. You subtract 2010 minus 1970 and you get it's a 40-year-old coin. Okay? So the age of circulating pennies are right skewed, meaning most pennies kind of have a lump on the left, and there are very, very few older and older pennies, right? So the shortest a penny could ever get in age is 0. Therefore, it's right skewed. Assume the ages of circulating pennies has a mean of 12.2 and a standard deviation of 9.9. So based on this information, can we determine the probability that a randomly selected penny is over 16? And the answer is no, because we don't. Oh, as a matter of fact, we know the shape of the distribution is right skewed. And therefore, we cannot use our rules of probabilities. Namely, norm dist, which is what we really want to use. Okay. All right, what is the probability that a random sample of 40 circulating pennies has a mean age greater than 16 years? But it's okay. This isn't talking about a single penny anymore. This is talking about 40 pennies. So let's just think about that for a second. Since it's 40 pennies, now we know the shape normal, because n equals 40 is greater than 30, which means we have a center, which is the mean of the x bars, the mean of the means, which is 12.2. And then we also have, oopsie, let me do this. We also have a spread, sigma x bar, which is sigma, oopsie, not fraction, sigma, there we go, divided by the square root of n, which is, what was sigma again? 9.9, there we go. 9.9 divided by the square root of, I gotta stop hitting that button, 40, which I just happen to have found already with Excel, is right here. 9.9 divided by the square root of 40, it's 1.565. So 1.565. Cool. All right. Well, if that's the case, then can I make a picture of this? Well, I already did. Look at that. So here's the distribution. 12.2 is in the center. This is for n equals 40. So let me get a picture of the area we're talking about here. We're talking about being between that curve and the one with 1.565. And they wanted it to be how? Random sample as a mean age greater than 16. Okay, so I'm going to go 16 to, and I'm just going to pick a really big number here. Add the graph. Okay, there it is, that little bit in the tail. I'll copy and paste it into the picture, into the notes, so you can get a sense of it. So it's not very much, just a little bit over there. All right, now how could I find that? Well, good question. Now remember that Excel doesn't find right tail probabilities. Excel finds left tail probabilities. So you want to do 1 minus norm dist, and then what was it? 16. The mean is 12.2. Oopsie. Standard deviation was the standard deviation of sample means, which is 1.565. True. And that little bitty bit in the area was 0.0076. Now again, it's 1 minus because it's a right tail area, and Excel doesn't find right tail areas. It finds left tail areas. Yep, 7.6. All right, not very much at all. All right, I don't have time to finish this last question, so I'll finish it in the next video. See you then.